Now let us focus at one of the most important values of sine, that is sine 180. Sine 180 can also be written as sine pi when we take the angles in radians. So 180 can be broken up as 90 plus 90. So what is our formula? Sin A plus B is sin A multiplied by cos B plus cos A multiplied by sin B. In this case, both A and B are 90. So we will have sin 90 multiplied by cos 90 plus cos 90 multiplied by sin 90. So what is the value of sin 90? Value of sin 90 is 1. Value of cos 90 is 0. Value of cos 90 is 0 again. Value of sin 90 will be 1. So 1 into 0 plus 0 into 1. So answer of sin 180 will be 0. Similarly, cos 180 will be cos 90 plus 90. That is cos A cos B minus sin A sin B. So we will have cos 90 multiplied by cos 90 minus sin 90 multiplied by sin 90. So what do we have here? Cos 90 ka value is 0 multiplied by cos 90, that is 0, minus 1 multiplied by 1. So 0 minus 1, cos 180 will be minus 1. Now look at what values we have got currently. You know the values of sine and cos from 0 to 90. So what are those what are the values that we are getting right now? Sine 120, we got the value as positive root 3 upon 2. Cos 120, we got the value as minus half. You can check. Sin 135 was 1 upon root 2. Cos 135 was negative 1 upon root 2. Then we had sin 150 as half, whereas cos 150 was minus root 3 upon 2. Sin 180 was 0, as you can see in this slide, and cos 180 was minus 1. Originally you can take sin 90 as 1 and cos 90 as 0. So can you see a trend emerging? If you look at the values of sine from 0 to 90, you get the same value. Sin 0 is 0, sin 30 is half, sin 45 is 1 upon root 2, sin 60 is root 3 by 2, sin 90 is 1. Okay. Now when we go from 90 to 180, sin 90 is 1, sin 120 is root 3 by 2, sin 135 is 1 upon root 2, sin 150 is half, sin 180 is 0. Okay. So if we want to better picturize this, can we say that when sine goes from 0 to 90, the value increases, something like this. When sine goes, so this is 0, then half, 1 upon root 2, root 3 by 2, 1. So this is 90 degrees. When sine comes from 90 to 180, the value decreases, but we get similar values. So you will have sine 120 as root 3 by 2, sine 135 as 1 upon root 2, sine 150 as half, sine 180 as 0. So you can compare sine 60 and sine 120. Both value is root 3 by 2. Then sine 45, sine 135. The value of both is 1 upon root 2. Sine 30, sine 150. Value of both is half. Sine 0, sine 180. Again the value is 0. Similar thing you can work out for cos. If you look at the value of cos 0, so what is the value of cos 0? Can I write it as 1? What is the value of cos 30? Root 3 by 2. What is the value of cos 45? 1 upon root 2. What is the value of cos 60? Half. What is the value of cos 90? 0. So, can you see a lot of similarity here? Cos 90 is 0. Now look at cos 120. Cos 120 is minus half. Cos 60 is half. Cos 135 is minus 1 upon root 2. Cos 45 is 1 upon root 2. Cos 150 is minus root 3 by 2. Cos 30 is root 3 by 2. Cos 180 is minus 1. Cos 0 is 1. So if we want to have a picturization of this, can we make it as somewhere here? Cos starts with 1, goes down to root 3 by 2, then 1 upon root 2, then half, then 0. So this was the value of cos 0, that is 1. This is cos 90, which is 0. Then what happens? Cos goes below as minus half for 120, minus 1 upon root 2 for 135, minus root 3 by 2 for 150, minus 1 for 180. So if you look at what is happening, you will see that in sine or cos, the values plus or minus, if you forget that part, remain somehow same. There is a pattern that is emerging. What is the pattern for sine? A pattern emerges for sine. Sine 0 is 0, sine 30 is half, sine 45 is 1 upon root 2, sine 60 is root 3 by 2, sine 90 is 1. Then again, that this is quadrant 1. So in quadrant 1, how did sine move? 0, half, 1 upon root 2, root 3 by 2, 1. In quadrant 2, that is from angle 90 to 180 or pi by 2 to pi, sine 90 is 1, sine 120 is root 3 by 2, sine 135 is 1 upon root 2, sine 150 is half, sine 180 is 0. So you can imaginarily take it as when sine is going from 0 to 90, it is rising in the steps of 0, half, 1 upon root 2, root 3 by 2, 1. 0, half, 1 upon root 2, root 3 by 2, 1. When it is going from 90 to 180, it is following the same steps down. Root 3 by 2, 1 upon root 2, half, 0. If you look at what is happening with cos, it starts with 1, goes down to root 3 by 2, then 1 upon root 2, then half, then 0. This is quadrant 1 when cos is moving from 0 to 90. Now when cos is at 0, it goes to minus half, minus 1 upon root 2, minus root 3 by 2, minus 1. Okay. So if you visualize this properly, you will find these values are easy to remember. The pattern is 0, half, 1 upon root 2, root 3 by 2, 1. If you fix this pattern, sine starts at 0 till 90, it is an increasing pattern. From 90 to 180, it is a reverse pattern or a decreasing pattern. For cos, it starts from 1 with a decreasing pattern, goes to 0. From 0 to 90, from 90 to 180, cos starts from 0 with a negative increasing pattern, goes to minus 1. Okay, please put some thought into what we are learning here. If you grasp the concept properly, you will be able to remember all values of sine and cos without much effort. Let us move on to the next slide. Now, this is a challenge for you. I want you to find the value of sine 210. By now, you have all the values of sine from 0 to 180. So, how will you go about 210? Sine 210 can be also written as sine 7 pi by 6. Can I split it as sine 180 plus 30? Of course, there are other ways to split it, but it is better that you split it with the points where you get a certain change, where the quadrant changes. So 0, 90, 180, 270, 360 is where the quadrant changes. So it is easier for calculation. So please calculate sine 210. Which formula you will use? Sine A plus B, which is sine A multiplied by cos B plus cos A multiplied by sine B. Here you will put the value of sine 180 as 0 and cos 30 as root 3 by 2. Then cos 180 as minus 1 and sine 30 as half. Please find the value. Similarly, find the values for all the trigonometric functions which are given here. I give you 5 minutes to crack these values. You can pause the video here and replay after 5 minutes. Now let us look at the solution. You should have got sine 210 as minus half, cos 210 as minus root 3 upon 2, sine 225 as minus 1 upon root 2, cos 225 as minus 1 upon root 2, sine 240 as minus root 3 by 2, cos 240 as minus half, sine 270 as minus 1, cos 270 as 0. If you have got the values, you are getting the hang of the formulas properly. Please check your values. Moving on, some more sums to do. Sine 300. How will we get 300? 270 plus 30. So please solve these sums. Check your answers. Sine 300 is minus root 3 by 2. Cos 300 is positive half. Sine 315 is minus 1 upon root 2. Cos 315 is positive 1 upon root 2. Sine 330 is minus half. Cos 330 is root 3 upon 2. Sine 360 is 0. cos 360 is positive 1. Please check your answers. If you have got this, please try and find a pattern when sine moves from 180 to 270 and when sine moves from 270 to 360. Similarly, find a pattern when cos moves from 180 to 270 and cos moves from 270 to 360. At 360, you will realize sine has reached again the starting point, which is 0. Cos has reached its starting point, which is positive 1.